Slide 1. Introduction to Advanced OOP. Welcome to today's presentation on Advanced Object-Oriented Programming. We will review basic object-oriented concepts briefly, then dive into advanced techniques. Understanding these concepts helps create efficient and scalable software. Slide 2. Inheritance. Inheritance lets classes derive properties and methods from other classes. This makes your code reusable and organized. For example, an animal class can have a method called speak, and a dog class, derived from animal, can have its unique implementation of this method. Slide 3. Encapsulation. Encapsulation keeps details hidden and protects data within a class. It manages data access by using public, private, and protected attributes. For instance, a bank account class can protect the balance attribute by only allowing it to be modified through specific methods, like deposit. Slide 4. Polymorphism. Polymorphism allows different classes to respond uniquely to the same method call. This increases flexibility in your code. For example, a cat and a dog class both have a speak method, but each provides a different response. Slide 5. Abstract classes and interfaces. Abstract classes define methods without actual implementations, forcing derived classes to provide specifics. This ensures consistency across your application. An abstract animal class can enforce a speak method that all derived classes must implement. Slide 6. Design patterns. Singleton. The singleton pattern ensures a class only has one instance throughout your application. It's useful for managing resources that should only exist once, like a configuration manager. Slide 7. Design patterns. Factory. The factory pattern creates objects without specifying the exact class. This allows your code to be more flexible and adaptable to changes. For instance, a factory can create a cat or dog object based on user input without directly specifying the class to instantiate. Slide 8. Real-world application. Advanced object-oriented concepts are widely used in real-world applications. Web frameworks such as Django and Flask, game development, and large-scale software applications all rely heavily on advanced object-oriented techniques for maintainability and scalability. Slide 9. Best practices. Writing clear and concise code is vital. Follow the solid principles, which promote good object-oriented design. Keep your classes small, each focused on a single responsibility, making your code easier to understand and maintain. Slide 10. Resources and further learning. To learn more, consider these valuable resources. The book Design Patterns, Clean Code by Robert C. Martin, Python's official documentation, and tutorials on RealPython. Continue building and refining your skills with practical projects.